Question number 21. Find the expected value for the following distributions. Um, we have the formula for expectation value for the given variable x. So the expected value of the variable is given by the summation of the product of the variable value times its corresponding probability. So if you use that formula, the first value is 1 into the corresponding probability is 0.23, plus second value is 2 times 0.38, plus the third one is 3 times 0.32, plus the last one is 4 times 0.07. Okay, so if you simplify this, you should get 2.23. So that is the expectation value of the given problem. So selection B. Problem number 22. What z value corresponds to 76% of the data less than z value? In other words, complete the following statement. That means you need to find the z value where the probability of that value less than any value should be 0.76. That means if you draw a picture for this, suppose if you have a C distribution, so they are asking us to calculate the particular C value in such that anything else less than that value area should be 0.76. Okay, so we don't know this value, so we are going to find the z value if you know the left area. So you could use the calculator. So the z value is given by the inverse norm function with the left area is 0.76. Okay, since I'm using a z distribution, you don't need to mention about mean and standard deviation. So default values are 1 and 0, so you don't need to put. So if you find that answer, it is going to be 0.71. Therefore, my corresponding z value is 0.71, which is again choice B. Problem number 23. Find the area under the standard normal distribution curve between z negative 1.43 and c 0.81. Okay, so if you draw a picture for the z distribution here, sorry, and now you need to find the area between negative 1.48 to 0.81. So we are asked to find this area, in between area. So I'm using the calculator. So area of the normal distribution curve is given by normal CDF function. So you need to put the bounds, right? So this, the left point is negative 1.48. Oh, it is a 43, right? Okay, that's a correction. Sorry for that. It should be a point or 1.43, right? So it is negative 1.43 to 0.81. So if you type this one, so you will get 0.715. Okay, so that is choice C. Problem number 24. The average time a person spends shopping in a supermarket is 52. If the time is normally distributed with the standard deviation 9, find the probability that a person spends less than 59 minutes for shopping. That means here they are asking us to find the probability of the variable which is less than 59. Here my variable x, we don't know, this is the question now. The x is my variable x here, the time the person spends, right? Okay, so now we are asked to find this probability. Remember, this variable x is now normally distributed. So that means I could use the formula for the normal distributed. So we are asked to find the area. So if you draw a picture for this problem, now you don't have z. Instead of that, I have x. So suppose if this is 59, they are asking us to find this area. Okay. So now I'm going to, use the area formula. Remember, if you are asked to find area, you have to use normal CDF. Since x is normally distributed, I could use that function, normal distributed. So therefore, it is a normal CDF function. Okay, my bounds, my left bound for this area is now a negative infinity. So therefore, that is negative 99. And this side bound is 59. Okay, now you have to define your mu value here. The mean of the problem is given. If you read the question carefully, the mean, the average time, the mean time is 52. Therefore, you need to write here 52. And what is the standard deviation for this problem, which is 9. So remember, when you use normal CDF function, right? For the standard normal, you don't need to define this. Calculator has always the default value. So if it is not, standard normal, if it is simply normal, then you have to define your mean and standard deviation for the particular problem. Okay. Now type this and you will get the answer as 0.782. Please check this. Okay. So that is choice C. So problem number 25. The average time a person spends shopping on a computer in a week is 14 hours. If the time is normally distributed with the standard deviation 4, find the area or probability that the mean time for sample of 20 shoppers will be between 12 and 15. Okay. Now, here you have to understand the question carefully. So we need to find the probability of what? The mean time for the given problem. Okay. Suppose if x is, the time spent, then x bar is now average time or mean time. Okay. So the question is, they are asking us to find the probability of the mean time. That means this x bar. Okay. So that x bar should be between 12 to 15. So you need to find this probability, okay? But the given information is about, the time, not the average time, okay? So the given information for the time. So that means, so here, what do they mean? They mean that average time a person spend on shopping computer in a week is 14. So this is nothing but mu, right, for this variable time, okay? So mu for this x variable, which is given 14, okay? And the standard deviation is 4. There's no confusion. These two values are for the variable x, okay? The time spent that person. But the question is finding the probability of x bar. Remember, we have results we saw in the class. If you know the distribution x, which is normal, so x is normal with the mean normally distributed with mean 14 and standard deviation 4, then x bar, right? Average time, x bar has a mean. So we denote this as a mu of x bar. That guy is equals to the mu, that means the mean of the original. And the standard deviation for x bar, so we denote that as sigma x bar. That is given by the standard deviation for x, then divide by the number of samples. Okay, so if you look at this problem, there are 20 surplus they have taken into this array. Therefore, n is 20 here. Okay, so understand carefully these things. So now we know the distribution of x bar. X bar also a normal distribution because of the central limit theorem we had in our, in the class note. We had these things, and make sure that you understand clearly. So you have to read the question carefully. Okay, since I know now x bar distribution has mean mu, so what is mu here? Mu is given 14, but here the standard deviation for x bar is little sigma, which is 4 over square root n, n is 20, so 4 over square root 20. So if you simplify that, you should get, what is that? I got 0.894. So that is my standard deviation for x bar. Okay, so now we know standard deviation for x bar and mu for x bar. Therefore, I could find the area of the given problem now. So therefore, this area, I'm again you're going to use the calculator. Okay, so that is, if you draw a picture for this problem, picture is like now. Remember now my distribution now is x bar. We are finding, the area for x bar. But since this is a normal distribution, so you have the curve like this. So the mean for this problem is this value 14, right? And the standard deviation is now 0.894 for this problem. So now we are finding which area? We are finding the area between 12 to 15. Okay. Now this is the area we are going to find. So area, normal CDF. The bound for this problem is now 12 to 15. The mean for this problem is 14. And the standard deviation is 0.894. So now find this value. So that is going to be your area for this problem. So it should be 0.8561. Okay, so that is choice D. 6. A sample of 10 millet netted in a pond had a mean weight of 2.3 pounds with a standard deviation of 0.3 pounds. Find the 90% confidence interval for the mean. Okay, so if you look at the problem, you are given a sample, the size is 10, and the sample mean is 2.3, and the sample standard deviation is 0.3. Since you know the sample standard deviation, you have to use T interval formula. Okay, so you could use either the manual way or the calculator. So let me use the calculator now. I'm going to use the calculator. Okay, so that is basically T interval formula you have to use now because you don't know the population standard deviation. Therefore, let me show that, and we are going to use stat. I need now T interval number 8. Okay, so we are going to enter our data values now. X bar is 2.3 and the standard deviation is 0.3 and the sample size is now 10. And what is my level of confidence for this problem? 90.9. So then calculate. So what is the answer there? So 2.12 and 2.47. 2.12 and 2.47. So where's that? This is close to B, right? Is that 2.12 or 2.13? It is 2.13, 2 decimal places. So that is choice B. Okay, problem number 27. Again, sort of similar problems, but now you know the population standard deviation. Therefore, we are going to use the z interval for this problem. So use the things again. N is 40, and the x bar mean is given, that is 2.3. Now you know the population standard deviation, that is now 0.3. Okay, so now I'm using a z interval formula. So therefore, the z interval for this problem is, let's look at. If you use the calculator, go to stats and test, and now I need z interval 7. Okay, so now let us enter all the values now. So standard deviation 0.3, x bar is 2.3. Now n is I need 40. C value is 0.9, so remaining all fine. So just calculate. It is 2.22 and 2.38. 2.22 and 2.38. So it's going to be E, right? Okay. So understand clearly about between these two. So if you know the population standard deviation, then use the z interval formula for mean. If you know the sample standard, then go for the t interval for mu. Okay. Okay, so if you want, you could do the manual way also. So we have the formula for that, and but you need to find the the critical value T alpha over 2 and Z alpha over 2, right? If you want to do manually these two. But I believe this is the shortcut, easiest way to do this problem. Okay, 28. If the population standard deviation of a national accounting examination is studied, how large a sample is needed to estimate the true mean score within 5 points with 99 confidence interval? Remember, this problem is about what? The population, the problem is now you are estimating the mean, right? So remember, under the mean, the margin of error. So you can go and check our note. The margin of error for for the confidence interval for mean is given by, we use big E as a margin of error. So this is equals to what? The margin of error formula we had, which is Z alpha over 2 times sigma over square root n. So we had this formula. So you could go and check your what we had. Okay. So I'm using that margin of error formula. So only thing is now you should know, these values. Okay, we don't know n, so we are going to find, the minimum value of n we could pick to get this estimation. And that means you should know z alpha over 2 and the population standard deviation. So the population standard deviation is given for this problem, that is 30, right? But the confidence interval is now 99. So if you draw a picture for this, we could find the z alpha over 2 now. So I'm going to find the z alpha over 2. So now this is alpha over 2 and this is alpha over 2. So this is my negative z alpha over 2, right? This is positive z alpha over 2. What is my alpha over 2 here? So the confidence level is now 99. The remaining 1% divided by 2 is a half percentage. So that is how much it is? It is 0.005, right? So this side also 0.005. Now, if you use the calculator, so you could find this value by inverse norm function. Use the inverse norm function of left area to this point is 0.005. So if you use that, we could find the left z point. So I'm using inverse norm function. So that is a 0.005. So what is that? That is negative 2.58. So therefore, this is negative 2.58. This should be positive 2.58 then. So you know now z alpha over 2. So plugging those two values, you will get E, right? Therefore, my margin of error E should be now 2.58 times sigma is 30. I don't know n, I'm going to find n. Now this margin of error should be within 5. That means this should be smaller than 5 in such a way that you need to figure out the n value. Okay, so now this is kind of inequality. You have to solve this inequality for what? For n. Since I have square root in here, I'm just squaring both sides to get rid of the square root. Okay, so now I'm squaring both sides. So if you square both sides, this will be 2.58, right, squared times 30 squared over, if you take the square of square root n, then square root will be get rid of, so you will get just n. That side also you have to square, that is 5 squared. So now you need to simplify this. Okay, so you need to simplify this. So if you simplify, then what you will get, but here is 5990 times 5590.76 over n, that is, this side is 25. Okay, now cross multiply by n both side, and just cross multiply both side, and you will get, so you will get 5990.76, and bring this guy down, and this should go on that side. So now simplify this one. So you should get here 239.63. That means what? That means your n should be bigger than this value. In such a way, you could pick your sample size n. Remember, n is the whole number, the number of the data values you are picking. Therefore, the possible smallest n value is 240, right? So that means we could pick n as a 240. Okay. So if you look at your answer, you should get that is the sample value we will get, how large our sample size should be. So it should be 240. That is choice B. Okay. Problem number 29. A survey of 600 women shoppers found that 22% enjoy the shopping for shoes. What is the 95% confidence interval for the true proportion of women shoppers who enjoy the shopping for shoes round to the nearest thousand? So this is about finding the the interval for the proportion, right? So remember we had the proportion interval formula. So that is the left hand point is p hat minus z alpha over 2 times square root p hat q hat over n. So this side is the same thing but with the positive sign, plus sign. Okay. So now the thing is you need to figure out the p hats. They say that 22% of women they use that, therefore 22%, that is 0.22. So if p hat is 0.22, then q hat is 1 minus 0.22. So that is 0.78, right? Okay. So now we need to find the interval for 95% confidence. So therefore, if you draw the z, so this is my z alpha over 2. So 95% confidence interval, that means this is 2.5% and that side 2.5%. So 2.5% is 0.025. So now find this value, that is inverse norm of 0.025, right? So what is that? 0.025. So you should get negative 1.96. So that is my negative z alpha over 2. Therefore, this side is 1.96. So we know z alpha over 2 and you know the little n, right? So what is my sample size here? Sample size is 600. Therefore, plugging all the values into your interval, you will get the answer. Okay. So therefore, if you plug in the values, you will get 0.22 minus z alpha over 2 is 1.96, and the square root of p hat is 0.22 into 0.78 over n. N is 600. So this is my left hand point. So this will be bigger than this side, which is 0.22 plus 1.96 times 0.22 times 0.78 over 600. So simplify this and get the answer. So you should get the correct answer as 0.187 and 0.253. So make sure that you are getting this answer. So that is going to be choice D. Okay. Now, problem number 30. The academic of the Paris regions gives a survey results that 85% of the women wear shoes that are too small for their feet. The researcher wants to be 99% of confidence that his proportion is within 4% of the true proportion. How large sample size is necessary? Again, we are asked to find the sample size and we don't know. Okay, so now for the margin of error for the proportion now, margin of error for proportion problem. Okay, so again we use E. Now the things are a little bit different. Now here the formula is Z alpha over 2. Now you have to take this quantity P hat times Q hat over N. Okay, so now this is margin of error. So that is kind of difference in our interval formula. You see now you are adding and subtracting. This is going to be our margin of error, right? For all the intervals, for the mu, for proportion, and for sigma square, whatever you have. So whatever you are adding and subtracting, this is going to be our margin of error. Okay. So now since this is the proportion question, so my margin of error is this. So let us figure out now this one. So what is my confidence level here? So the confidence level is now 99%. So let us find out the corresponding Z alpha over 2 here. So now I need to know what? This is leftover half percentage, and this also a half percentage. Half percentage is going to be what? 0.005, right? So now if you figure out this guy, that is going to be inverse norm of 0.005. So if you do correctly, you should get negative 2.258. Therefore, this is 2.58. So you know that. Then what is P hat here? For the P hat for this problem is, so P hat is 85% of the women say yes for their survey. Therefore, P hat is 85%. That is 0.85. Therefore, Q hat should be remaining 15%. That is 0.15. So you know everything now plugging into this, so you could find the margin of error. Therefore, my margin of error E is Z alpha over 2 is now 2.58, and times the square root P hat is 0.85, then times Q hat is 0.15. Then you need to divide by N. N is the question. We don't know that. Now this is my, the margin of error. This guy should be less than, within means less than what? Less than 4%. So my error should be within 4%. So 4% is 0.04, right? Okay, now how do you solve for n? Like earlier we did, take the square both sides to get rid of the square root. So this is going to be 2.58 square. When you take the square of this, the square root will be, got rid of. So that's going to be 0.85 and 0.15 over n. So this side also you have to take the square. So the square of 0.04. Okay. So now simplify these guys, and you move this end that side. So you will get this will give you 2.58 square and 0.85 times 0.15, and move this guy to the denominator, and this side move to the the right side end. So that means if you simplify this, so you should get a 530.4. That means your sample size should be bigger than any number 530.4. The closest one we have in our answer is 531, I believe. Yes. So 531 is the correct answer. Okay, so I'm choosing mine as a 531. Okay, one. For sample of size 23, find the left and right chi-squared values for 98% confidence interval. Okay, so this is super easy problem. Now we are going to look at the chi-square distribution for the problem. So you have left and right points. So this is alpha over 2, then this is also alpha over 2. So this is my chi-square right point, and this is my chi-square left point. Okay, remember my confidence interval for this problem is now 98%. Therefore, this is remaining 2% means this is 1%, and that is 1%. So that is 0.01. So what is the degrees of freedom for this problem? So the degrees of freedom is the sample size is 23. Therefore, degrees of freedom is 22. So look at your chi-square table. So let me take my chi-square table. This is my chi-square table. So we are looking for the right side area is 0.01 with the degrees of freedom 22. So 0.01 is the second to the last. So 0.01. So I need the degrees of freedom 22. So degrees of freedom 22 with 0.01 will be 40.289. That is 40.289 is my right side point. 40.289. Okay. So if you find your left point, then so find the left point. So again, go to your chart, and the left point should be 0.1 minus 0.01, which is 0.99. So it is the second column with 22. That is 9.542. 9.542. Therefore, where's my answer? My answer is C, right? Okay. Number 32. A sample of 9 US states found that the standard deviation of life expectancy is in this area was areas was 2.3 years. So you know the standard deviation for the sample. So the sample size is 9, and the standard deviation for this problem is 2.3. Okay. What is the 90% confidence interval for the variance of life expectancy? Right. So that means remember the formula we have. The variance interval formula was n minus 1 s squared over chi squared right. This side n minus 1 s squared over chi squared left. And first figure out chi squared right and left. So what is my confidence level for this problem? This is chi squared. So the confidence level for this problem is 90%. Therefore, this is 5%. So that is 0.05. So the degrees of freedom for this problem is we have sample size 9. Therefore, this is 8. So this is my chi-squared right. This is my chi-squared left. And look at the table and find out chi-squared left and right. I explained last time. Okay. So if you look at chi-square left and right, you should get, please check with my answer. So I got chi-square right as a 15.507. and chi-squared left as 2.733. Okay, so now plugging all the values, now you know everything, right? So little n is the sample size 9, so plugging all the values and here and find the sigma squared. Okay, so in -1, 9 minus 1, and s squared, s is 2.3, so 2.3 squared over chi-square right is now 15.507. So this side should be 9 minus 1 times s squared is 2.3 squared over chi-square left is now 2.733. So take your calculator and simplify this. So this would be 2.729, and right point should be 15.485. Okay, so if you round up this to one decimal place, so you should get 2.7 and 15.5. Okay, that is part this choice C. Okay, so let's look at problem number 33. Using table E means the table I gave you, Z distribution, standard normal distribution table. What are the critical values for two-tailed test when alpha is 0.08? Okay, remember. So if you draw a picture now, so this is about the Z distribution, table E. So this is my alpha over 2, and this also alpha over 2. So this is going to be negative Z alpha over 2, and this is Z alpha over 2. And what is my alpha over 2 then? Alpha is 0.08 divided by 2. That is 0.04. This side as well, 0.04. Therefore, we know how to find the left point easily. So this is inverse norm of 0.04. So find this from your calculator, and you should get. So what is the answer I got? So I got this answer as negative 1.75. So that means this is negative 1.75. So this will be positive 1.75. So these are the two critical values, plus or minus 1.75. So if you look at your answer, yes, it is there, the last choice, right? Okay, problem number 34. According to the Manly Men magazine, the national average age of a male model is now 23.2. This is my national average mean, population average, population mean. A sample of 16 prospective male models in Dallas revealed that their average age was 24.6. So it is going to be my sample mean. And the sample standard deviation is now 2.8. We may claim that the average age of a male model in Dallas is greater than the national average. At alpha 0.01, what is the test value for this hypothesis test? Okay, so if you set up the hypothesis for this problem, actually mu is now 23.2. And our claim is here, the average should be greater than that. That means my H1 should be right tail test now. Okay, so we are looking for the test for mu when you know the sample standard deviation. Therefore, this is nothing but the t-test. Since this is the right tail test, if you look at the picture for the critical value, so now this is a t distribution, and now this is right tail test. So this is going to be my given alpha confidence level or significance level, in another word. So this is 0.01, right? That means this is my critical value. Okay. So then what is the test value for this hypothesis test? So they're asking us to find the test value, not the critical value. So how do you find the test value? So test value formula is given by, since this is the t distribution, which is x minus mu over s over square root n. You can go and check your notch. So this is x bar is given now 24.6 minus mu is 23.2 over the standard deviation is 2.8 over square root n is 16. So make sure that you put the parentheses here to get the correct answer. So if you simplify, you should get exactly 2. Okay. Or you could use the calculator easily. So let me show that method. So go to the test. Remember, we are under t-test now. T-test is number 2. And we need to give the data values. Now, a mu naught means a mu for our problem, which is 23.2. And the x bar, the sample mean was 24.6. And the standard deviation for the sample is 2.8. And sample size is 16. And this is, of course, a right tail test, so greater than sign. That's it. So you simply calculate. So the calculator value t means the test value. So the test value is 2. Yes, exactly, we got 2. Okay, so this is the easiest way, So t is 2. Okay, so that is choice A. So 35. For a left tail hypothesis test for population mean with the population standard deviation. Okay, so we know now population standard deviation. That means we know sigma, which is 4.1. So that means we have to use now z-test. Okay, so alpha is now 0.01. So the question is now left tail test. So you need to look at now left tail test. This is going to be our alpha now. So this is critical value. So now alpha for this problem is 0.01. So this is now z. Okay. So you could use either calculator or do manually. So you know all the things, right? So all the test values are the statistics values are given. Mu is 20, x bar is 18, and n is 35. Okay. So there's no way to find critical value by using the test in calculator, but we could find separately critical value first. Since this is a z, my critical value is given by now. Remember, this is left-hand point. So therefore, this is simply inverse norm of 0.01. Okay, inverse norm of 0.01. So if you find that, that should be negative 2.33. Please make sure that you are getting correct answer. So that is my critical value for this problem. To find the test value, so you could use this formula. Remember, we are under z-test. So therefore, x minus mu over standard deviation over square root n. So x bar is now 18 minus mu is 20. Then this over standard deviation for this problem is 4.1 over square root n is 35. Simplify this. So if you do correctly, you should get negative 2.89. So this is my test value and this is my critical value. Okay, or you could use the calculator for the z-test. Okay, so therefore, where's my answer? 2.33 negative and negative 2.89. So it's going to be choice D, right? So that is choice D. Okay. Problem number 36. Now this is also for the left tail hypothesis test, but you know the sample standard deviation now. So you are given now you are given now mu value. Mu is now 20. X bar sample mean is 18. Sample size is 15. But now you know the sample standard deviation S, which is 4.1, right? Therefore, this is about the t-test now. Again, this is a left tail. So now this is my alpha. So we have alpha for this problem, 0.01. So this is my negative T alpha over 2. That is my critical value. Okay. So to find that, remember when you use the table for chart for T distribution, you should know the right side point, right? Okay, so now I'm finding the right side for 0.01. That means you will get positive T alpha over 2. Then you should know the negative because of the symmetry. So what is the degrees of freedom for this problem? N is 15, therefore it is 14. So I'm checking my T value for 14 and 0.01. So I'm under now T distribution, 14 and 0.01 is my second column, and 14 will be 2.624. 2.624. Okay, that is my critical value. To find the test value now, you have to use this is T distribution, x bar minus mu over s over square root n. So x bar is now 18 minus mu is 20 over s is now 4.1 over square root n is now 15. So simplify this answer. So you should get the test value there. I got that as a negative 1.89. Please make sure that you are getting this number. Okay. So find this. So this is my test value. So my critical value is this and test value is that. And that means you don't find any answer here, but there's a typo in your answer. So make sure that you are getting the correct value. So that is going to be none of these. Problem number 37. Bottles of Coca-Cola are supposed to contain 16 ounces of drink. So that is our population mean. An inspector measures 20 bottles and find that the mean of 20 bottles for the sample is 15.94 ounce with the standard deviations for sample is 0.3. So alpha is 0.01. Can the inspector claim that the mean weight is less than 16 ounces? So if we made the hypothesis now, so mu is now 16. So we are claiming that mu may be less than 16. So this is a left tail test. Right. So now we are going to, if you look at the choices here, so this is my hypothesis setup. Right. So now, what about these values? These all our critical values. Z is my test value, right? So we will find the critical value for this problem first. Since this is a T distribution problem, because you don't know the population standard deviation, we know the sample. But this is a left tail test. So this is my left side area. So this is my test value, right? Sorry, critical value. So how do you find the critical value? Like earlier we did. Right? But now, what is the degrees of freedom for this problem? Degrees of freedom is 19. So now I need to find the, the T value with 0.01 with degrees of freedom 19. So the degrees of freedom 19, 0.01 is the second last column. Okay, 0.01. So now degrees of freedom 19. So what is that then? So 19 will give you 2.539. It should be 2.539. So my T alpha over 2 is 2.539, but since I need to have a negative 2.539. Okay, so that means if you want to reject your hypothesis, you have to have your test value in this region. That means your test value, right? So test value should be less than this value, right? To reject. So now let us look at our answer. Of course, we use T distribution problem. Therefore, if you look at, you should have T values in your choices. So only there are two possibilities. These are the only two we have with the T value. Okay. But if you want to reject, you should have your, the test value here. That means your test value should be less than negative 2.54. That means it is going to be this one, right? Therefore, my choice is C. Okay. Okay. So problem number 38. A recent comprehensive survey found that the 71.4% of the national population owns two cars. In a random sample of 150, therefore that is going to be my mu is that for mu? No, it is for the proportion problem. So I need to change that to proportion notation. So this is the proportion problem. So the given one is the population proportion P, that is 71.4%. And you know the sample size, right? Okay, out of 150, 111 says yes. Therefore, we have P hat, that is 111 over 150. Okay, so 111 over 150. So what is that? So if you find that number, so it is going to be, so I got my answer as 0.74. Then Q hat should be 1 minus 0.74, which is 0.28. Okay. Okay. So that is here. What else we need? So we need alpha. Alpha is 0.05, right? This given. Okay, the question is now, does this sample data indicate the difference from the national proportion? Okay, so let us write down now hypothesis now. So my H naught is going to be now, you know, the population proportion problem. So I'm using little p. That is 11.4%. That means that is 0.114 number. And my alternate hypothesis is now not equal sign. So that is a two-way test now. So if you draw a picture is like a two-way test now. Remember, so we are using a z distribution for the proportion, right? So this is z alpha over 2 and this is negative z alpha over 2. So that means this area is 0.025 and this is also 0.025. So if you look at your z alpha over 2, so z alpha over 2, negative z alpha over 2 is inverse norm of 0.025. So you should get negative 1.96. So that is by z alpha over 2, which is a positive 1.96. Okay. Okay, so everything is here. The question is now, you need to find the critical value. Okay, I know now the critical value. That is this. Okay. So now what is my test values? You need to find the test value also. So here it is given test values. So let us find the test value. Remember, for the proportion, test value is given by problem. You can look at your notes, the test value, which is actually our z value, right? Because we used the z test. So this is going to be, so p hat minus little p over square root p times q over n. So you can go and look at. Okay, so what is that? That is a p hat we have, which is 0.74 minus little p we got, that is my hypothesis value, or null hypothesis value, 0.714 over square root little p again 0.714. Oh, I need to know the little q. So little q is 1 minus little p. So that is, this is you know, the population proportion, which is 0.714. So if you subtract, you should get 0.286, right? So that is my little q, 0.286 over n. N is here 150, the sample size. Okay, so carefully simplify these guys. You will get 0.7. So that is my test value. Okay, so the test value is now positive 7.7, and my critical values are, you know, critical values are positive plus or minus 1.96. Okay, so that means you reject you reject your hypothesis whenever you have the test value either here or here, right? So your test value may be less than negative 1.6 or bigger than 1.96, right? So therefore you will reject either here or there, okay, with the z value is zero point 0.7. Okay, so you reject h naught when your critical value, that is your critical value is this one. So if your test value is falling in this region here, that is a negative 1.96, or your test value z stand for my test value. Test value may be here as well because we have now two regions. So you will see test value may be bigger than this 1.96. So this is, and with your test value, which is zero point 0.7. Okay. So if you look at your answers, this is exactly matching with choice A. Problem number 39. A left tail test is used when, okay, so these all problems are true or false, first three problems here. For the next three questions, choose A for true or B for false. So the question is now, left tail test is used when H naught is mu bigger than or equals K or mu is equals K. Okay, if you want to use the left tail test, your null hypothesis should have less than sign. Yes, that is correct. Your alternate hypothesis should have less than sign. So yes, we have that. Therefore, this is the correct statement. When conducting z-test with alpha 0.05, the test value was 1.58. Okay, remember? So when you perform two-way test for z-test, of course, so this is my z alpha over 2, and this is my negative z alpha over 2. So my alpha is now 0.05. So alpha over 2 is 0.05 over 2, which is 0.025. So this side also I have a 0.025. So look at these, but they are not asking about the critical value, right? So they are asking what? They are asking our test value. But anyway, we will find the critical value as well. So critical value for the left point is negative answer you should have, but that is inverse norm of 0.025. So inverse norm of 0.025. So what is that? So if you look at correctly, so you should get negative 1.96. So this is positive 1.96. Okay. So you are given a test value, of course. Test value is 1.58, right? So 1.58 will be somewhere here. So it is clear that the test value is now falls in a non-critical region, non-rejection region. Therefore, we do not reject H naught. So we do not reject H naught. Yes, this is correct statement. Problem number 41. The critical chi-squared value for 10 degrees of freedom for the following figure is 3.940. So the degrees of freedom is 10. With the left area alpha is now 0.05. So look at your charts and check whether you are getting 3.940. Could you check? So if you check, let me draw a picture first. So this is my chi-square. We are looking for now right side point. So this is my alpha 0.05. They are asking us to find out the right side point. We know how to find and check with the degrees of freedom 10. So I got this answer as 18.307, but the given value was 3.940. Yeah, this is not correct with my answer. Therefore, this statement is false. So we are in last problem. To the last problem. For right-tailed chi-square test with alpha 0.05 and the sample variance 1 and the population variance is 0.644 and we have sample size is 19, then what is the critical value and the test is statistic? So okay, so if you draw a picture for this, and this is right tail test, so you have alpha here. So problem says that alpha is 0.05 with the degrees of freedom is now 18. So that means so you will find out chi-square right value. So let's look at my table there. This is chi-square 0.05, that is my fourth column from the last, with 18 degrees of freedom. So 18 with the fourth column will be 28.869. 28.869. Okay, so that is my critical value, of course. And what is my test value then? To find the test value, we use the test statistic for variance problem. So you could check your note, which is n minus 1 little a squared over sigma squared. Okay, so n is here 19, therefore 19 minus 1, and the sample squared is now 1 over the standard deviation is sigma squared 0.644. So you just simplify this. So this will be 27.95. So this is my test value. So this is my critical value. So they are asking which one first, the critical value first. So your answer should have a 28.86. Two decimal places will be 28.87. So that is your first answer, 28.87. With 27.9. So you could pick the closest answer. Yeah. So you could pick this. Okay. So answer is C.